This video is part 2 for the Combinations of Transformations worksheet. Before we begin actually working out some problems, I just wanted to review the rules that we've been using for the past couple of weeks. We have our rules for reflections, rotations, and translations, which those are all of our rigid transformations. We also have the rules for dilations and then some facts about dilating lines and translations and rotations with parallel lines and how they are related to reflections. And also, again, as we discussed in our last video, a 360-degree rotation will always map a figure back onto itself, so that's just a nice fact that you want to have memorized. So for the rules here, we have all of our rules for rotations. So we have 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees, which can go either way. It doesn't matter, as we talked about in class. We have our rules for reflections. Now, with regards to reflections, we only have rules for 4 specific lines. So if you are reflecting over the line y equals 0, which is the x-axis, remember this is the line y equals 0. It's a special name for it. We call it the x-axis. And this is the line x equals 0, which we call the y-axis. So those 2 particular lines, as well as the lines y equals x and y equals negative x. So if it's not one of those 4 lines, there is no rule for manipulating the coordinates. You have to graph the line of symmetry, or the line that you're reflecting across, and then once you graph your preimage, you just count from each point to the line of symmetry and reflect that to the other side. And again, we've done lots of practice of that in class. So there's only rules for these 4 specific lines here. And then for translations, those are the ones that are easy, so don't make them hard. Oftentimes these rules are written together, but I've separated them to just make them a little more clear. So if it's a horizontal translation, then you are adding or subtracting from the x coordinate, because that's telling us whether to move the figure left or right. And if you are translating something vertically, then you're adding or subtracting to the y coordinate, because that's what tells us how far to go up or down. And of course, you can do both in the same problem. You can shift it left or right and shift it up or down, and then it'll be like a diagonal translation. So those are all the rules that we've been using, and now we're going to apply them to some of the problems on our worksheet. So the first thing we're going to do is read. So this is number 7 on your worksheet. We have triangle LMN, and they give us the vertices. They tell it's a triangle, they give us the vertices, and they want us to label and graph, and they want us to perform 2 transformations on it. So they want us to rotate it 90 degrees clockwise, and then translate it using this rule here. So there's a couple things we've got to do. So the first thing I'm going to do is highlight my original coordinates here, and then we're going to be performing 2 different transformations. So we're going to be rotating, and then we are going to translate it. So I actually have 3 different triangles that are going to be on this graph when all is said and done, because I'm going to go ahead and graph the original image, preimage, excuse me. Then I'm going to graph the 90-degree counterclockwise rotation, and then I'm going to graph once we've translated it. And of course, in the end, you only need the final image, which is after we've rotated it and translated it. But because we're learning and we're practicing, I'm going to go ahead and just do this step by step to try and make it easy for you guys to follow along. So first of all, let's go ahead and graph our triangle. So let's see what we have here. We have 1, 1, and that is L. We have 1, negative 2, 1, negative 2, and that is going to be point M. And we have 3, negative 3, which is going to be point N. So there is our preimage. I'm going to use my straight edge here to graph. I'm going to move that letter because it's in the way. So we're going to graph our triangle. Okay. Now I'm going to rotate it 90 degrees counterclockwise. So I can do a couple of different things. I can just change my coordinates, which I think I'm actually going to do here. And then we can check it with the patty paper. So if I go back up here to my coordinates, I'm going to apply the rule for rotating 90 degrees counterclockwise. So that rule is right here. So for every one of my points, every one of my points that I have here, I'm going to change the sign of the y and I'm going to swap them because that's what the rule tells me to do. So for L, if I change the sign of the y and swap them, I'm going to have -1, -1, +1 for L prime. M prime, if I change the sign of the y and swap them, I'm going to have 2, 1. And N prime, if I change the sign of the y, I'm going to have +3, +3. So those are my coordinates for just the counterclockwise rotation. So we're going to go ahead and plot those on our graph. So I'm going to come back over here and let's go ahead and use a different color here. So we have -1, +1, -1, +1, that is going to be L prime. Then we have 2, 1, which is going to be M prime. And then we have 3, 3, which is going to be N prime. I just didn't count properly right there, so let me go ahead and fix that. So this is M prime, and 3, 3 is right here, which is N prime. So let me go ahead and graph that triangle. Here we go. And always use a straight edge when available. If you don't have a ruler and you're trying to do this on a quiz or a test, fold a piece of paper in half and it'll give you a nice straight edge to use. So if I just go ahead and check that real quick with my patty paper. Here's my original 3 points and I'm rotating about the origin, 90 degrees counterclockwise. So if I rotate my paper, you guys can see that we did that correctly. So that's awesome. So that's the first transformation. So let me come over here and just copy down my coordinates. I had -1, +1, then I had 2, 1, then I had 3, 3. All right, so that is for the first transformation, and I'm going to go ahead and color code that. Since I highlighted it orange in my problem, I'm just going to highlight that here so that I know that this is the points after I've rotated. And then last but not least, we have to translate our shape. So we're going to start from here. We're going to start from our second triangle that we've graphed, and we're going to translate it using the rule x minus 4, y plus 2. So if we look at this here, what this rule is telling us is that we are going to shift this left 4 and up 2. So if you just want to mark that on your paper, this is going to be left 4 and this is going to be up 2, just as a little reminder as to what we're going to be doing. So every single point on this triangle is going to be shifted left 4 and up 2. So for L prime, I'm going to go 1, 2, 3, 4, 1, 2. So this will now be L double prime. For M, we're going to go 1, 2, 3, 4, 1, 2, and that's going to be M double prime. And last but not least, we have N prime, so this is going to be 1, 2, 3, 4, 1, 2, and there is our final image. You guys can see that, right? And let me mark it. And make sure that you mark your notation on your graph, otherwise it's very hard to see which point goes where, which point we're talking about. So I'm going to go ahead and use my straight edge. And let's go ahead and write our final coordinates here. So for L double prime, according to my graph, I have -5, 3. For M double prime, I have -2, 3. And for n double prime, I have -1, 5. And again, I'm going to go ahead and just highlight these so that I can see the coordinates afterwards. And we can go ahead and highlight this. So this was after we translated it. Use my pretty pink highlighter here. And the orange was the first transformation. And yellow is where we started. All right, so let's just review this problem and see what we did here. So of course we read our problem. They gave us the vertices. They gave us 2 different transformations to perform. The first thing that we did is we rotated it 90 degrees counterclockwise about the origin. So that gave us these orange highlighted coordinates over here. Then we went from here and we translated it 4 units to the left and 2 units up. So this is our final image here once we have performed both of those transformations. Okay, so that's it for number 7. Let's go ahead and try another problem on the back here. Let's go to number 8, the ocho. All right, so here we are given triangle XYZ. We're given the vertices, and again, we're going to label the points, and this time we're going to perform 2 reflections. So again, I'm just going to color code this so I can keep track of what I'm doing. So these are my original points here that we're going to graph. Then I'm going to perform 2 transformations, 2 reflections to be specific. We're going to reflect it first over the x-axis, and then we are going to reflect it across the y-axis. Okay? All right, so our first point is at 1, -2. So let me zoom in here. We have 1, -2 on the graph. That's going to be point X. Then we have -2, -2. That's going to be Y. And we have 0, 0. And that is going to be Z. So let's go ahead and connect the dots here. I'm going to highlight that because I like to color code my notes. All right, so the first thing we need to do is reflect across the x-axis. So we can use our rule there, but I'm actually just going to count because counting is very simple, very easy to do. So I'm going to grab a different color pen here, and if we're reflecting over the x-axis, that is this line right here, and I'm actually going to go ahead and highlight that so we can see what's going on here. So I'm just going to highlight my x-axis. Okay, so the x-axis is our first line of symmetry. So what I'm going to do is I'm going to count from each point to the line of symmetry and mirror that onto the other side. Now Z, right off the bat, we see that Z is on the line of symmetry, so it's 0 distance away, so therefore we don't have to move it. It's going to stay right there. X is 2 down from the line of symmetry, and so we're going to mirror that by going 2 up. So X prime is going to be right here. Y is also 2 away, so Y is going to go up 2 to the other side. And Z prime is going to stay in the same spot because it lies on the line of symmetry. So let's go ahead and connect the dots here. So we have our triangle, and I'm going to go ahead and highlight that, and we will write our coordinates. So that has been mirrored over the x-axis. So if we write our coordinates here, x is located at 1, 2, x prime, excuse me, y prime is located at -2, +2, and Z did not move, so Z is still at the origin, right? And just as a little review, if we had just applied the rule for reflecting about the y-axis, let's see if we would have come up with the same coordinates here. So reflecting across the x-axis, this tells me that I just need to change the sign of my y. So if I hadn't counted, like I did a second ago, and just changed the sign of my y coordinate, let's see if we wouldn't have ended up with the same coordinates here. So we would have had 1, 2, -2, +2, and 0, 0. So whether you apply the rule or just count and list your coordinates, you guys can see that we came up with the same points either way. All right, so the last thing we've got to do here is we've got to reflect across the line y equals x. So we also have a rule for that in our notes, but again, I want to show you guys how to count because if you're just applying the rule and you're not careful with your signs, you can make a mistake and not catch it. However, if you're actually graphing it and you're counting yourself, it becomes much more difficult to make a mistake since you can actually see it. So I'm going to go ahead and graph the line y equals x, and this is not the line y equals x. I accidentally graphed the line y equals -x, so let me go ahead and correct that. So y equals -x has a negative slope. Y equals +x should be going the other way. So let's do this the correct way, shall we? I'm going to go ahead and graph that. And the reason I'm making this a dotted line is because this line is invisible. It's actually not part of the graph. The triangle is the only part that's actually on the graph here, but that's the line of symmetry that we're using. So we're going to reflect this triangle, the orange triangle, about the line that we have there. And I'm also going to color code that one. So this is y equals x. Right there. Now to make this easy on us, what I'm going to do is I'm going to rotate my paper so that the line of symmetry is vertical because it's easier for me to see. And then I can just count. So my line of symmetry is vertical, so if I look at x, I'm one diagonal, or I should say half a diagonal away from the line of symmetry. So on the other side, I'm going to mirror that, and that's going to be x double prime. Z is again on the line of symmetry, so that one's going to be the same. And then y prime is 1, 2 away from the line of symmetry, so it's going to be 2 away on the other side, and that's going to be y double prime. So if we go ahead and graph our figure here, that is what our triangle is going to look like once we reflect it over that line. So I'm going to go ahead and highlight my triangle. And let's go ahead and list our coordinates. So x double prime is at the point 2, 1. I'll zoom out here so you guys can see. So x double prime is at the point 2, 1. Y double prime is at the point 2, -2. And z didn't move. Okay? So just out of curiosity, if we had just applied the rules, let's see if we wouldn't have gotten the same thing for y equals x. So according to my transformation rules here, all I have to do is swap the x and the y. So if you guys look at x prime to x double prime, I swap the x and the y, I get the right point. I swap the x and the y, and of course 0, 0, if we swap, doesn't make a difference because they're both the same. So you can see that the rules worked either way. So our final image is this triangle that's highlighted in pink. So it's x double prime, y double prime, z double prime. All right, so let's jump down here and do the quadrilateral. Those were pretty basic, so let's go ahead and jump down here and do our quadrilateral. So we have a quadrilateral, we have some vertices, we're going to label the points and graph it. We're going to perform a reflection and then a rotation. All right, so let's go ahead and try this out. Let me highlight what I'm doing here. I'm going to reflect it over this line, and then I'm going to rotate it 270 degrees clockwise, which, if you guys recall from class, about this point. I'm actually not rotating about the origin, so I'm going to do a little more work there. So let's go ahead and plot this. Oh, for 270 degrees clockwise, that is the same as 90 degrees counterclockwise. So we don't have 270 degrees written in our notes. However, if we're going 270 degrees around the coordinate plane, that's the same as if we went 90 degrees the other way. All right, so let's plot our preimage. We have negative 4, positive 4, and that is C. We have negative 3, 0, which is D. We have 0, 2, which is E. And we have 0, 4, which is F. So we have a quadrilateral here. I'm going to go ahead and use my straight edge to connect the dots here. It's so quiet in here, I can hear my clock ticking. All right, here we go. It's very loud. It's making me nervous. All right, so let me go ahead and highlight that one. Color-coded notes are the best. All right, so the first thing we need to do is we need to reflect this over the line x equals x plus 4. But that is not going to fit on my graph. Well, we can change that so it fits on our paper, but I want to make sure that we actually do this problem. So let's just go ahead and do it over here. It's not going to fit on my graph, so I'm going to make a more bigger graph. So let's do this again real quick. Sorry about that. The good thing is I haven't already printed 100 copies. Oh wait, I already did. That's okay. We'll just do this on a separate sheet of graphing paper so we can do it the right way. Let me plot those points again. So this is 0, 2. This is E. F. D is at 0, 3. Or excuse me, negative 3, 0. And F, or C, my original point was at negative 4, 4. All right. So if you guys don't have graph paper, get some. Graphing paper saves lives, just like it did in this video. All right, so we've got our preimage graphed. Now we're going to reflect this across the line x equals y equals x plus 4. Okay, so the first thing I need to do is graph that line. So if I want to graph the line y equals x plus 4, just as a little friendly reminder here, if we compare this to slope-intercept form of a line, which this is in, the slope is 1, which means we're going to go up 1 and to the right 1, and the y-intercept is 4, which means we start there when we're graphing. So the y-intercept is actually right here on top of point F, and I'm going to go up 1, right 1, up 1, right 1, right here. Oh, this looks like it will fit on my graph. Oh well, I don't know. We'll just continue. We'll just continue here. Maybe I'm tired. All right. So if we plot this on here, if we go ahead and plot this on here, we're going to reflect it about this line. So this will actually fit on your paper. I don't know what's wrong with me. I must have my positives and negatives flipped today, so sorry about that. So we're going to go ahead and reflect this. Now, because this is not y equals x or y equals negative x, our only option is to rotate the paper and to count. So we're going to go ahead and do that here. So F is on the line of symmetry, so I don't have to move that. So C is 1, 2 away, so C prime is going to be right here on the origin. E is 1 to the right, so to mirror that, I'm going to go 1 to the left. That's going to be E prime. D is half half a square away, so it's half of a diagonal, so I'm going to mirror that to the other side, and D prime is going to be right there. And like we said, F is on the line of symmetry, so F prime will also be on the line of symmetry. So if we make our quadrilateral here, connect our dots. So I know that that kind of looks crazy, but that's why I rotate my paper vertically so it's easy to see. So the quadrilateral that we just drew is right here. Let me highlight it. Right here. So if we took our original quadrilateral and mirrored it over that line, you guys can see that that is symmetrical about this dotted line right here. All right, so let's go ahead and list our coordinates. So our coordinates on our graph, let me fold this so we can see it more easily. Our coordinates according to our picture here, the coordinates of D prime, oh, and I'm short a blank too. That's okay. We'll just fill it in down at the bottom. So D prime is located at 1, 2, 3, 4, 1. E prime is located at -2, +4. +4, and this one's also negative, sorry about that. F prime is at 0, 4 still, and C prime is at 0, 0. Okay, so those are our coordinates for our quadrilateral, and let me go ahead and color code those so you can see. Now what we're going to do is rotate this figure 270 degrees clockwise, which is the same as 90 degrees counterclockwise. Let's go ahead and do that. So I have my picture, and I'm going to go ahead and just use the patty paper here to save time. But what I would normally have to do by hand is subtract the point of rotation, rotate it, and then add it back. So if I rotate this 90 degrees counterclockwise about the point 2, 1, 2, 1 is right here. So if I rotate my paper 90 degrees counterclockwise, it's going to look like this. So I'm going to pick my patty paper up and mark those points. So that looks like I'm at 3, -1 right here for, that's going to be C double prime. Then I'm at 2, 1, 2, 3, 4, 2, -4 right here, 1, 2, 3, 4, 4. That's going to be D prime, D double prime. Then we're going to have F double prime right here. And last but not least, we'll have E prime, or E double prime right here. All right, so let's go ahead and connect our dots. So all we're doing here is doing more than one transformation on the same figure. Looks a little skinny, doesn't he? Let's double check our transformation. We started here. We rotated 90 degrees about the 0.21. Ah, okay, that's why I'm confused. All right, and then D double prime I don't have far enough down, so this should be down here. So when you're performing a rigid transformation, remember that it preserves side lengths and angle measures. So the second that I saw that my quadrilateral, it was a little too skinny, need to be a little fatter, that's why I went ahead and double checked myself. So if you're working this out and you plot the points and it doesn't look like it's the same size, or that it's congruent to your preimage, then you know that you've most likely made an error. All right, because if you're performing a rigid transformation, the size and shape should not change. So there's nothing wrong with making an error. That's the beauty of graphing it, because visually it's very easy to see if it's the correct size or not. Okay, so our final coordinates here, and let me add my C double prime down here for our image. We're just going to list the points right here next to our graph. All right, so the final coordinates for D double prime, let's see, that's going to be 3, and that's 1, 2, 3, 4, 5. So that's 3, -5. E is -1, -3. F double prime is -1, -1. And C double prime is 3, -1. All right, and if we color code those. Now for the last question here, they give you the coordinates of the preimage and they give the coordinates after 2 of the transformations have been performed. So you basically have to go through and test each one of these to see if it in fact gives you the same